In this video, we're going to talk about Lewis acids and Lewis bases. The Lewis definition of bases describes bases as electron donors. This is different from the Bronsted-Lowry definition of bases, which describes them as proton acceptors. Lewis acids, then, are electron acceptors, whereas in the Bronsted-Lowry definition, acids were proton donors. In this example here, we have hydroxide, which in this case is serving as a Lewis base because it is donating a pair of electrons, and I'll highlight these electrons here in blue. So those electrons over there are being donated to form an oxygen-hydrogen bond. The Lewis definition is talking about the electrons being donated, whereas before we described this as a Bronsted-Lowry base, and in the Bronsted-Lowry definition, we said that this base would be accepting protons. So it is a base both by the Lewis definition and by the Bronsted-Lowry definition. Now let's look at our acid. Our acid over here is accepting electrons. So this is our acid. It is accepting electrons from the base. And if we want to color code these electrons, that HCl bond comes over here to form a lone pair on the chlorine. This is also an acid based on the Bronsted-Lowry definition because it donated a proton. So this is an acid both using the Lewis definition and the Bronsted-Lowry definition. Remember that when we're drawing our electron flow arrows, our curved arrows, that we're going to be using these to represent acid-base reactions. And we did this a lot in chapter 6. This is yet another example. And we can see that this is a base both using the Lewis definition because it is donating a pair of electrons. And we can also see that it is a base with the Bronsted-Lowry definition because it is accepting a proton. So if we follow electrons here, the blue lone pair of electrons on NH2 here becomes the nitrogen-hydrogen bond on the right, and the hydrogen-oxygen bond here becomes a lone pair on the oxygen. So our acid then is methanol over here on the left side, and again it is a Lewis acid and it is a Bronsted-Lowry acid. A Lewis acid because it is accepting electrons, and a Bronsted-Lowry acid because it is donating a proton. Let's look at some examples of Lewis acids and bases that are not Bronsted-Lowry acids and bases. So for example, look at BF3 over here. BF3 is a Lewis acid, but it is not a Bronsted-Lowry acid because it doesn't have any protons to donate. So what's happening here? Boron, remember, has a valence of 3. So it has 3 bonds, but it doesn't have an octet. And that makes it highly reactive and wanting to accept electrons. Over here is our Lewis base that is donating electrons and forming that bond there that you see here in red. This ether is a Lewis base because it is donating electrons, but it doesn't have any protons that it's accepting. The acid is accepting those electrons, which makes it a Lewis acid. Here's one more example. Our Lewis base is donating electrons, donating that red pair of electrons to form a bond, and the Lewis acid is accepting that pair of electrons. And you can see those pair of electrons forming a new aluminum-nitrogen bond. Aluminum is below boron on the periodic table, and just like boron, it likes to accept electrons. So we call AlCl3 a Lewis acid because it can accept those electrons. Again, AlCl3 cannot be a Bronsted-Lowry acid because it doesn't have any protons. Now, NH3, ammonia, here is acting like it's Lewis base because it's donating electrons. It's not accepting protons, but it can be a Bronsted-Lowry base, as we've seen in several examples in Chapter 6. This concludes our brief introduction to Lewis acids and Lewis bases, and we're going to see a lot more Lewis acids when we talk more about reactions.